Hi there, welcome back to the shop. I just finished this oil or chip pan for my lathe bench, and I've got all the lathe components ready, so today we're going to start reassembling and getting the lathe bolted down and ready to make some chips. Let's get into it. I think the first order of business is going to be bolting the legs back onto the lathe bed. We'll get that set on the bench and use some transfer punches to mark where the bolts are going to go. Are you a good shop cat? Are you killing crickets? What do you think? So I have all the mounting holes drilled. What I did is I drilled them out. Coffee, you got something to say? Meow. Alright. Anyways. What? What? Come here. You being talkative? You want to say hi to the camera? Huh? Anyways, somebody wants some attention. But as you can see, I've got the mounting bolts for the lathe bed installed. What I did is I drilled them and then reamed them so I have a nice tight fit. And I'm not actually going to install the washers and nuts and tighten them down until I have this bench in its final position and bolted to the floor, because then I need to level the lathe bed, which will probably require installing some shims between the lathe and the bench and then tightening those bolts down. So no real point in doing that now. Plus, as I tighten down the headstock and other sub-assemblies, that's going to change how the bed sits slightly. So I'm just going to leave those bolts loose for now. Right? All right, why don't you go kill some more crickets or something. There you go. This cutout and lathe bed here is for the large back gear, which sits down below the level of the lathe bed. So I can't just slide the headstock on. So I have to be careful when I insert this down into this slot and slide it forward that I don't hit this gear on the bed and damage a tooth. So this is going to be a little bit fiddly. I think that's on there. Now, there's two cap head screws on the back of the headstock that I'll install that provide alignment, and then I'll tighten up this bracket on the front. The headstock's all reinstalled and tightened down. Now I did have to take the lathe bed bolts out and roll it up, and then I was able to reach up through the legs of the bed to hand tighten this bolt, because you can't actually get a wrench up in here. And then once I had that hand tight, I was able to insert the wrench from this end to do the final tightening. The headstock is keyed into the bedways, so that should all be taken care of alignment. But again, once we get up and running, we're going to check all the alignment and make sure everything's running as true as possible. Now I'm going to get on to reinstalling the saddle, tailstock, and quick change gearbox. One key thing, I almost forgot to reinstall the rack on the front of the lathe bed that the saddle engages on. So I'm going to do that first, and then we'll put the saddle on. I've got the saddle and cross slide installed, and I've adjusted the gibs, or preliminary adjustment anyways. So far it moves really nice. The cross slide was binding up at its furthest back position. I determined the cause of the binding was some of these shims. So the nut that the cross slide screw engages in is shimmed for alignment, and there were about 6 or 7 of these shims in there, and it was too many. It was pushing the nut out of alignment, so I removed 4 of the shims, and now it lines up well, and there's no binding when you back the cross slide all the way back. So that was an easy fix. And then I did some adjustments on the gib on the compound, and so that's moving nice and smoothly also. Now onto the tailstock. There's also a gib down in the tailstock between the ways, and that's adjusted by a flathead screw on either end, and as you drive that screw in, it jams the gib and presses it wider. So right now we have a little bit of play, so I'm going to get a screwdriver and we'll tighten those screws until we've removed the play, but it still slides smoothly. I don't feel any play. It's sliding smoothly, so that's looking good. The next thing we'll have to do is adjust the alignment of the tailstock with the spindle. And that uses these screws on either side of the tailstock, which moves the tailstock side to side. We'll do that after the lathe is up and running because we have to turn a reference bar to check for taper. I've reinstalled the headstock, the quick change gearbox, the saddle, cross slide, and compound assembly, as well as the tailstock. And it's gone pretty smoothly so far with the exception of one major issue, the lead screw for the carriage or saddle. Now, as I talked about in a previous video, the original lead screw, the threads on that were starting to wear down to more of a triangular form instead of the original factory Acme form. So my plan had been to make my own, but as you can see on this other lead screw, and at the time I didn't realize this, there is a keyway that runs down the entire length of the shaft. And I don't have a way to machine that in my current shop. And I didn't really want to hire anybody else out to do it. So what I did, I found on eBay someone was selling an allegedly new old stock lead screw that fit my lathe. I ordered it, it came in, it looked good, and it basically matched the original lead screw. The main problem is that when I installed this and was testing rotating it, it kept binding up. And I couldn't tell if I had something out of alignment, either with the quick change gearbox, the bearing block down at this end, or with the saddle assembly. And come to find out, the lead screw is just bent. So this new old stock lead screw, when you put it on a really flat reference surface and roll it, you could see almost 1/8 of an inch of gap at the worst point. But it was hard to tell without that reference surface, so that's what took me a while to figure it out. Unfortunately, I don't really have a way to fix that. You probably could straighten this with the right equipment, but I don't really have a way to do that in this shop. So what that led me to do is I just had to reinstall and reuse the original lead screw. In the future, I hope to maybe make a new lead screw for it or find an old broken lathe that I can take one as a donor. But for now, that's where we're at. So I guess just check your parts. I'd ordered that parts months ago, so unfortunately it's kind of too late to do anything about it. But that's all right, lesson learned, right? You order a part, check it right away, make sure it's going to work. So the next step here, we're going to reinstall the counter shaft assembly and motor, and then we'll move on to the guards, and that will basically wrap up the project. So let's get into that. Well, I finally have it all back together and I think we're ready to turn it on and see it under power. I've gone through everything, I've oiled everything on the machine, I've turned everything over by hand, I'm not seeing any binding, everything seems to be moving freely, so I think we're ready to give it a shot. What we are going to do though is, for this first time we power it on, I'm not going to pin the main drive gear to the cone pulley, so we really should only be driving the cone pulley here. The spindle may turn a little bit just due to the friction in the system, but once we confirm that that's working correctly, we'll shut the lathe off, engage the pin, and drive it under power. And then we'll just work our way up from there. We'll try the back gear, and then we'll try the quick change gearbox, then we'll start the power feeds, the cross slide power feed, and just see how everything works. I've also made sure to set everything as its lowest RPM. That way I have extra time if something does go wrong, and hopefully will reduce any possibility of damage. But I think we're going to be all right. Let's see how it goes. Awesome, that sounds great. So I'm going to open this. And you can see, just because there is friction between the pulley and the spindle, it is turning. Be very careful here. But now we will engage this pin to lock it into direct drive. That looks good. To the naked eye, it looks like it's running true. Let me go get a dial indicator. We'll see how the spindle is doing. So I might have some burrs on here. Let's roll it over by hand. So I've repositioned my dial indicator to the taper on the inside of this spindle, and I think I must have had some burrs on the outside because this is running dead nuts on. Now that we've verified the lathe is running smoothly with direct drive, we'll try the back gear. So to do that on the Atlas Craftsman lathe, you have to disengage this pin. This is really important. If you engage the back gear and try to start the lathe with this pin locked, the spindle and back gear are basically locked in place, and you're going to either break some gear teeth or stall out your motor or just squeal some belts. So make sure that you've backed this pin out so that the spindle is not connected to the drive cone pulley before you engage back gear. Now to engage back gear, just have to rotate the spindle a bit. It's meshed. We can turn it over by hand to verify that everything is moving properly. We'll close our guard, and now we will turn it on. Sounds like it's running smoothly. You can see here our spindle speed is significantly reduced. So back gear is good to go. Now I'm going to disengage back gear. I have to re-engage our lock. So now we're back in direct drive. And now we're going to start testing the quick change gearbox. So to do that, I believe down is feeding towards the headstock, and I believe up is feeding away, but we'll find out here in a moment. Sometimes again you have to rotate the spindle to get everything to mesh properly. And now we'll turn it on. Also I have the quick change gearbox set at the finest feed rate, or I guess it'd be the lowest rotational speed for the lead screw. And that looks like it's working normally. let it come to a stop. We'll try the other direction. And that sounds good too. I'll move you over and give you a shot of what the gear train is doing. Okay, so for our powertrain, you can see we have the motor on the smallest pulley going to the largest pulley on the countershaft. Over on the other side of the countershaft, we have it on the largest pulley going to the smallest pulley up on the cone, pulley cone drive on the lathe spindle. From there, the lathe spindle drives, these are our forward or reverse for the lead screw. So you can see here we're going from the spindle through one gear down to the rest of the train. If we engage this direction, we're jumping through two gears. So that's what reverses the feed direction. So we'll put it back in, and then if it's in the middle position, the spindle is not meshed, so your feed will not be engaged. Following the gear train down, this is just for changing your different feed speeds. This is a double gear, and then this is the slide gear that you slide to either the large gear or the small gear up here to determine your feed speeds. From there, it goes through another drive gear into the quick change gearbox. Now we're going to give the power feed a try. So on this lathe, some have lathes have separate levers for the power feed and for the threading, but on this lathe it's the same. So when this is up, power feed's disengaged. When it's down, power feed is engaged. And then the carriage moves depending on left or right, depending on which position this lever is in. So as you can see, the carriage is moving to the right. Now we'll change lead or feed direction, and we'll try going to the left. That's moving nicely. Now we're going to test the power cross feed, which is engaged by this knob down here. So probably not meshed quite right. Let's see. Oh yes. You pull it out to engage it and push it in to disengage. Now before we run the cross feed though, you want to lock your carriage in place. Otherwise, the carriage can move slightly on this lathe, and so you're going to lack precision if you're doing any powered facing cuts. So, as you can see, it's moving normal. Our carriage is locked left to right. We've disengaged the power feed, because if you lock the carriage and leave the power feed engaged for the carriage, you're going to have problems. So, again, I've got the lathe running nice and slow. I think I might actually put it in back gear for this one. No, it'll be fine. All right, so here we go. We're going to turn on the lathe. I can feel this knob moving. I pull it out to engage. Push it in to disengage. So that was backing out. Let's change it to the other direction. Turn the lathe on, pull it out, we've engaged the power feed. Pushing in to disengage. Now I'll unlock my carriage so I don't forget and try to run it with the power feed on. There we go. Well, we've tested everything for smooth and correct operation, so I think it's finally time to make some chips. Funny thing is, I don't actually have any good stock in the barn to use for a project. I do want to start off with a non-ferrous metal though, just to start to test out the lathe, and I don't want to put it through too much right off the bat. I also need the spindle and headstock to warm up from running for about 30 minutes per the manual, so I can do the final adjustment for the tightening on the spindle to take out any play in the bearings. So I've got this old hose fitting. It's made out of brass. It'll work as a material. We'll just make some chips from it. And as far as cutters go, I'm just using the cutter from the previous owner. It's ground pretty weird. It's got a weird, pretty sharp rake on it. I think they were also turning copper or brass. So it's definitely not a cutter I would use for steel without regrinding it. But it should work for just making a few initial chips. Let's give it a try. That worked really well. Obviously I'm cutting through the old threads, so it's an interrupted cut, hence a little bit of chatter, but that's to be expected. Also, I haven't finished leveling the lathe and bolting it down, so it lacks a little bit of rigidity. But so far so good. Let's try a little bit deeper cut. That looks pretty nice. Let's try it with the power feed. That works beautifully. We'll try the power cross feed and come across and try to face this. So what we'll do is we'll come in and touch off. Then we'll back out, come over just a little bit, lock our carriage. Got to switch direction. All right, here we go. Not too bad. As you can see, the lathe runs great. So I think that about wraps up this restoration. What I need to do is find the final resting spot for this lathe in my shop, bolt the bench to the floor, and then finish leveling the lathe bed and bolting it down. Then we'll have our maximum rigidity and be able to do some real good projects. As always, thanks for watching the channel. I really appreciate it, and I'll see you next time.